So, hello everyone. Buenos dias. In the name of Pierre and myself, welcome to this session on biodiversity forensics. Just a small housekeeping rule: if you're presenting, the pointer is working, but you need to signal to go to the next slide by doing this. So now I already went to the next slide, so we'll dive in directly. I was supposed to have kind of both, of course, this introduction and having a presentation, but we manage all the talks. Presenting my own research will be very limited, but I will give a broad overview of the need for biodiversity forensics. So why are we here in Colombia? Actually, I just also really love the Colombian coffees. So when I'm going, no, still one back, please. Yes. So this is Forest Watch, and you can really see where the deforestation has been happening since 2000, if I'm not mistaken, but also deforestation in blue. And now, if we go to the next slides, this is just the last couple of years, which is, I'm very happy to say, looking very good. So I can continue to drink my Colombian coffee with peace of mind. We also saw in the introduction today that Colombia does a lot of work in monitoring biodiversity, and I'm very proud that I was now able actually to visit this region. So this is basically showing since 2000, where you still, of course, everybody has some deforestation, but the reforestation is actually looking better than what they are losing as far as forest is concerned. Now, for EUDR, there's a very important date, which is 1st of January 2021. And if something is deforested after that date, it's no longer allowed to import coffee, cacao, soy, timber from those regions into the European market. Actually, this date is still valid, despite the fact that they now have twice postponed enforcing this. But the legislative framework is now in place, and this date is not changing. And in the future, unless they roll back this legislation, it would be a great pity, it will still be the 1st of January of 2021, where areas cannot have been deforested to produce these kinds of crops. So now if we go to the next slide, please. Next slide, please. So we have this really change in legislation context that helps to enforce preserving biodiversity. So specifically this EUDR, European Union Deforestation Regulation, also have this broader European Environmental Crime Directive. So that's why this session on biodiversity forensics was, for me, so important to try and organize. As this legislation context has changed, it means it's no longer just monitoring, but you also need to have this scientific analysis to present in courts when people are simply not playing by the rules. And thanks to this context, actually, I work at my botanic garden already since 2 years, working on projects like Garden, safeguarding biodiversity for policy makers, together with Pierre, my co-host here. But after a good year and a half, thanks to EUDR, I had this opportunity to start the MICE crop source investigations laboratory, where we actually analyzing crops for their mineral composition to be able to link that back to the regions that they have grown, to actually be able to make this kind of checks. If somebody claims their crops, whether it be coffee, cacao, soy, timber, are coming from a certain region, we, by analyzing the mineral compositions, can at least assess the likelihood of that. Of course, that needs a global database of all these regions, and that's why this project is something I do in very close collaboration with Victor de Black, who's also working at my botanic garden. He has a double affiliation. He's also connected with World Forest IT. They will try organize this global sampling of all different kinds of crops, timber, coffee, cacao, then analyzing mineral composition so that we have this global database to then test samples that are coming into the European markets. So I presented part of this work just a month ago, also in EUDR, because next to doing mineral composition analysis, you can also try to use Earth observation data that also already tells you a lot about which minerals you might find in different regions. And we had a very fruitful discussion together with Tom Hengel here. Next slide, please. And Johannes Rijke, can still go to the further slides. On having this analysis ready data. So when you're working with Earth observation data, there's a lot of processing you need to do just to get you something intelligible, just to be able to look at those images and have some kind of understanding from it. Next slide, please. So together we then have this kind of, you have a concept of analysis ready data, but you can also have further step in the policy ready data, when you really are able to start using this data to have data-informed decisions for policy makers. And then, I contributed, of course, next slide, please. Between doing this kind of forensics. So a little side note, a good 10 years ago, I actually did my PhD on forensic DNA analysis. And so that's really my background. So for me, this is a little bit coming home. So that's why I'm making this kind of comparison between the work we're now doing at NICE and analyzing the crops and the work I previously did on DNA. But using this kind of state of the data, kind of go over this process of having analysis ready, hypothesis ready, then policy ready, and finally having forensics ready. Now, analysis ready, for me, it really means that you can make basic correlations. You can see correlations, and you need to have calibration and validation and sample metadata already in place. And then if we consider forensic DNA analysis, which is known throughout the world, that means already having clear allele frequencies and calibrating the PCR and electrophoresis instrumentation to actually have to use for that. But for analyzing crops in a biodiversity forensics context, it means having already an idea how your sample composition is, which types of species are actually in there, knowing something about those elements in the soil, being able to calibrate also the instruments you're using. In this case, that's the inductively coupled plasma optical emission spectrum. So basically, we're dissolving samples in acids, and we're then introducing them into an outgoing plasma to get light signals for the different elements that are present there. And so to really get analysis ready, we then also need certified reference materials just to check that our laboratory is making proper analysis. Now, the next step from getting from this basic analysis ready step and going to hypothesis ready, which is already, let's say, how we consider science, is being able to go from correlations to causations. And that's where we need to have well-constructed reference databases. And we need to really start assessing the bias that are in the analysis at the more basic level, but also in how we are building up our database. So for biodiversity forensics, that would be having, knowing the crops, the regions it's coming from, using herbariums to get this global overview of the the mineral compositions for different crops, and having soil and isotope price baselines for those elements, and working together with global databases like ECD. To make this analogy, with forensic DNA analysis, that's where you have this population substructure databases and national databases that collect DNA from people. So this is just getting basically your labs, whether it's forensic DNA lab or biodiversity forensics lab, just getting it ready. Then going to policy ready, it's adding the policy makers and interpreting and visualizing that data. And you need to have origin likelihood maps. There's knowing how the train is actually flowing. And at this point, we would want to have EUDR compliance overlays to see this crop, the claim is coming from that region. We're able to assess that likelihood and how does that match with what we're expecting from EUDR. In the case of forensic DNA analysis, there's also a lot of statistics already to get to this kind of match probability and the likely ratios. All this initial part is really very scientific. Then we get government and policy giving direction to what we actually need to deliver to help as scientists to have this kind of law enforcement. But you can only go to the courts and stand behind your results as a scientist if you know how much uncertainty it is. So for me, that's where you need to jump from policy to having something forensics ready. And I put here good stats, but you really need excellent stats. And you need to really be sure of all the biases you have to do all kind of workflow. So next slide, please. So this is why I think it really is time for biodiversity forensics, although in the introduction, you know that in a way, we're not even ready for being policy ready, right? This living data is to get to the policy ready. My argument is saying, despite the need to aim to get policy ready, we do need to think ahead. And part of the things are actually aligning and thinking about the uncertainty in the analysis you are making. That's already helping you to be forensic ready as well. But if you look to Wikipedia and to forensics, of course, the forensic DNA analysis, that's one of the most known one, but at this point, you will not yet find biodiversity forensics. So I hope this session that we have here is a first step in making that happen. So now I just have one last slide. So all the institutions that I have worked with now, also Warden, for which Pierre is actually the coordinator. That's a project that we're now wrapping up, and that kind of gave the initial thinking about why biodiversity forensics is needed. So thanks for coming to the session, and thanks for your attention. Gracias. So that's it. It's for my parts, and I'm now happy to, well, I don't know if there's time for questions. There's no time for questions, but you have a. Yeah. Okay. So we can now go ahead to the, that would be a virtual presentation from Gahila Vargal. I hope I pronounced the name correctly. So beautiful yet highly poached, the European goldfinch in the southern left. Yes. As we're waiting for, oh, we're ready? If anybody has a question, or
session, no one has.
yes, but in the room, you can discuss it at the end. Have the meeting.
What is?
David Bloom for I have the best one for you.
How about you?
Yes, it's now video.
Of course. I get a feeling.
Yes.
I'm going to.
Yes. Thank you.
Hi, everyone. My name is Christophe Van Neste, and I would like to thank the organizers for the opportunity to give this talk. I do apologize for the audience not being there in person. Today I'm going to talk. Hi, everyone. My name is Christophe Van Neste, and I would like to thank the organizers for the opportunity to give this talk virtually. And I do apologize for the audience not being there in person. Today I'm going to talk to you about this beautiful songbird, the European goldfinch in Israel. So as the head of the Human Forensic Lab in Israel, we get between 35 to 50 cases a year. Most of them are dealing with mammals, avians, and domestic animals. Among the avians, there are two abundant species that we see, the chukar and the European goldfinch. Lately, in the last 2 years, we see more and more of the Eurasian black cap in the forensic cases, which being poached for So the European goldfinch is a small bird that the body size is between 12 to 14 centimeters. It is well known for its singing, as you can hear from the background. And the name of the bird in Arabic is El Abud, meaning the blue, because of the beautiful, colorful appearance of the bird. In Israel, there are two species. One that is stable in the country, and one that migrates mainly between Egypt to Israel. The problem of the golden jackal in Israel is that a lot of individuals are being smuggled into the country, and if they are not smuggled, they are being poached in Israel. They caught them in the wild by using one individual, usually an adult, that when he is tied into the tree and he's singing or calling for help, the others that are coming are being caught. Because of its beautiful appearance and singing, when you sell one species from the wild, one individual from the wild, it will cost about $150 to $230. But if you train them, if you take the juveniles and you train them to sing a specific song, then the price can get up to $1,000. Here, for example, is the Israel Nature and Park Authority found individuals that are being the bait in order to catch other golden fish. And as you could see, they are all strapped around, and the stripes goes behind their wings. And when you take it apart in order to release the individual, it is very important that you will pay attention not to harm the wings, as the stripes are around the wings of the bird. Another problem that we face is that when we're trying to release them, and that because they are so small and stressed, they can die at the moment. So another problem with the golden finch is the migration of the golden finch with the Atlantic canary making the banduk. The reason for doing that is to get the songs of the canary, which are definitely the European golden finch, but to get the nice coloration and features of the European goldfinch and make this hybrid. When you train this hybrid to sing specific songs, you can sell one individual up to 3,000 more. So the research goal was to build a database and characterize the golden finch population in Israel for conservation efforts. Versus the Atlantic canary and the hybrid, and to identify the local population versus the imported population through the country. So the cohort consisted of 215 individuals. Most of them were smuggled into the country, some of them from unknown origin. Others were confiscated where you don't know whether they were smuggled or they are local. So therefore, we had to use that museum sample to identify the local population in Israel, and of course the two other species, the banduk and the canary. The museum samples actually are samples collected at the late 60s, early 70s, and hopefully they represent the local population that we had before this increasing phenomena of smuggling the species into the country. So the database that was established included morphological characterization, identification of species based on mitochondrial gene fragments, and population identification based on short-handed repeats. The morphological characterization took the regular measurements of body length, wing, tail, leg, and beak. And as we can see, we try to find differences between the different populations. Nothing was significant except of the body length between the museum samples and the smuggled population number one, and beak, leg, and tail between the museum samples and smuggled population number two. The banduk population differs from all the others, and also the smuggled population that was kept in the zoo was different from the others. The phylogenetic tree, based on 5 gene fragments of the mitochondria, shows that all these established primates can differentiate the species, and as you can see here, clearly they can distinguish between Atlantic canary, the hybrid, and the European golden finch. Among the European golden finch, the museum samples that are marked in pink are divided among the different clades of golden finch, and this is not highly supported by any bootstrap. So in order to identify the individuals and the population, we had to develop an SPR panel. We sequenced 25 loci, found 13 that fit, and then we saw some of them to be monomorphic, ended up with 12 markers that we could use. The analysis of the short-handed repeat showed clearly that the population of the smuggled European golden finch was much more diverse, more alleles that differentiate between them, more effective alleles there, and definitely a very low station index means that there is no genetic differentiation between them. The principal component analysis divided the smuggled population into two. One group is the smuggled number two, and the other is the unknown smuggled number one. What we can see is that the hybrid, the bundle, fit in both population, and also the museum samples, they fit with more with the smuggled number two population. If you know from where it came from, it will be very important. The assignment test of this sample individual shows that in most of the cases, we didn't get the correct assignment, except for smuggle one and smuggle two. What's interesting is that, especially the museum samples that did not fit the correct group that were assigned. And here, I'm not sure whether it's really reflecting the truth about this population, or because the profile was not fully built on 12 sites. This problem is also seen in the structure analysis, where the museum samples fall within the hybrid or the canary. But if we put them aside for a moment, what's interesting is the different haplotypes that we find in smuggle number one and smuggle number two, not originating specifically from one place. So to summarize the database that we built, we see that the morphology significantly differentiates the museum samples from the true smuggled population with body length, feet, leg, and tail. We managed to establish markers that can distinguish significantly between the species, but within the species, they do not have a strong bootstrap support. We couldn't find any structure. The SPR panel that we built can identify individuals, can differentiate between the species, but it's not clear among the smuggled population who is who in the group. So our conclusion is that the established database can help forensic cases, and we have an urgent need to increase our basket specimens of local European golden finch from the wild and from the museum samples, and at the same time get some voucher specimens from Europe, mainly Ukraine, because that's the place that's where they are smuggled from, and to try and actually identify local versus smuggled population. Thank you for listening.
So is Gila available for questions online? Or you don't think so?
No,
Or,
no, she's not.
she's not connected. Okay. So, you want to introduce the next?
Yes, yes. So we will continue with the presentation of Sébastien Léon-Bégigo, who is a PhD student from the INRIA. The presentation online of the metric agnostic framework for multi-species presence absence threshold. So it's Sébastien Léon-Bégigo. Great, thank you. Thank you very much.
Hello everyone, and thank you for the today's session. I would like to present work on the threshold forum in species prediction, which led us to the development of the metric agnostic framework. So let me start first with a bit of context. Our work is based on the concept of species distribution model, also called ECD. So species distribution model aims to model how the present species is linked to environmental variables, such as temperature, bathymetry, or profile. It tries to answer a simple question: is a given species likely to be present at a given site, given the local environmental condition? So to do that, we rely on spatial observation. For each location, we record whether the species has been observed. This is like whether 1 for presence or 0 for nested. This observation are then combined with environmental covariates, such as the temperature or precipitation. And using these inputs, the attempt can be trained to estimate for every site the probability that the species is present. The result is probability map showing areas with higher or lower likelihood presence. The model can of course become more complex, for instance by including multi-species or different types of numerical data, such as satellite or project networks. But the general principle remains the same: predict species presence. So why is this important? First, it allows to predict species distribution in areas where no direct observation are available. This helps fill in knowledge gaps and guide the result of biodiversity survey. The same principle can be used to measure environmental changes. For instance, to assess how the rise in global temperatures will affect species of present. And second, they help us understand ecological issues, meaning the environmental factors that determine whether a species can persist in a given area. So here is a simplified view of an Indian pipeline. Under a certain condition, the output of an SDN can be interpreted not just as a pseudo-species score, but as the estimated probability of species present. However, in many applications, we don't need probability. We need binary prediction. We want to say whether a species presents or absent. To do that, we have to insert a data into the pipeline, which takes the probability in inputs and outputs the prediction. In other words, we must define for each species and for each site a threshold above which the model predicts presence and below which predicts absence. This thresholding step also affects how we evaluate the model, since we know when the prediction and observation are both binary. That also raises the question: for a given site and for a given species, how can we determine probability threshold? In the literature, this step is overlooked, and there is no unified guidance for probability thresholding program. The best method to calibration data, that is, using additional data to tune the threshold for a given evaluation metric. However, this method is never efficient, so there are sensitive to this relationship. They need calibration for every metric studied, They also are sensitive to strong events between presence and absence. So for rice species, for instance. To address this issue, we developed an algorithm called Matrix. It can efficiently produce the call for a model made by the mathematical expression and directly optimize prediction with respect to the evaluations to be considered. The frameworks provide theoretical guarantees that it reaches the optimal solution for the trouble matrix. However, whether it's property formed in the real library for application needs to be tested. And that's why we focus on our basic. We tested robustness of macros through 3 case studies, with different taxa on areas. So we have first European world. Second is the Australian cover features. And the third is a data set of American birds. We are also using different modalities and methods, such as satellite data, time series, spectral array on different providers. And we are also using different models, so multimodal testing on based in scientific model. And the goal is to compare maximum threshold methods to other reference results. We using to score the this method for core metric, F1 score, F2 score, check on zero sets. So for the results, all of the sets and metrics you can do that when first then compared to those 25 methods which are integrated on with the distribution shifts or on trade sets. Maxent show also consistent performance with calibrated method on sets that shows the same distribution as the sets without distribution shifts. So this result indicates that Maxent perform well in practice, in addition to the theoretical properties. So to conclude, the necessity to predict species satisfies use of decision function. In the literature, the impact of this standardization are often overlooked. The developed Maxent framework shows consistent improvements in performance compared to reference methods and could be key. But there is also room for improvements, such as extended to account for species interdependencies. Okay, that's all. So I want to thank the team on the institutions helping me with this project. I also want to thank you a lot for your invitation.
It's Sébastien, hold on. Question?
I don't think that people in it.
No, okay. Here it was possible, but okay. So then we can go to in-person presentation, of course, of Amy.
Yeah. Yeah. Carlos, ¿no?
Maybe during the presentation I can myself. I'm very proud of Sierra. I work on the video and stuff and I'm back in the year in the Sunday farm. Yeah. It's just like we do Netflix. Okay. So, I will introduce you to GeoPubNet, platform for high resolution biodiversity mapping that can be used for environmental biodiversity. So, thank you, Christophe, for the session. This project has been developed within the European project Mambo and Water over the last 2 years. So the increasing frequency of environmental crime, for illegal deforestation to habitat biodiversity requires new tools for evidence collection, monitoring, and legal enforcement. So while GeoPubNet was primarily designed for ecological research and conservation planning, it also presents potential for environmental forensic application. It helped transform biodiversity observation into auditable and legally usable data. Next one. So GeoPubNet is based on NotNet, an AI powered citizen science platform that helps people identify plants with their phone. NotNet has over 20 million users worldwide, contributing plants observation through a mobile app or the website. It provides one of the largest geo-reference datasets, ranking among the top 5 global countries to be. My colleague Pierre will present you more detail in the presentation. So next, please. So, GeoPubNet is an open source web-based platform that transforms these millions of plants observation into biodiversity maps. The core of the platform is also based on AI, specifically species distribution model. We just heard about it in the presentation. So yes, SDM are designed to estimate where a species is likely to occur based on known observation and environmental variables such as climate, soil, or topography. They rely on the ecological concept of the beach, as a combination of environmental conditions that define where a species can survive and reproduce. So by modeling the niche of each plant, we can predict its potential distribution across space. Next one, please. So GeoPubNet extends this classical approach with a deep learning architecture called DeepSDM, capable of modeling thousands of species at once. The DeepSDM models integrates high resolution environmental features, including satellite images, so RGB, near-infrared imagery, elevation, and land proximity. It also integrates climate variables such as temperature and humidity, provided as the 20-year time series. And finally, long-site time series covering 20 years. These are all our values. The model is trained on around 30 million genetic occurrences and 5 million surveys from IBAs, the European Vegetation Archive, predicts the presence of thousands of plant species and their associated habitats. So, next slide, please. So, how does it work in practice? GeoPubNet is trained over Europe in level 4 region as spatial units. We divide the extent into metatiles of 20 by 20 kilometers. Each metatile is then graded in 5 meter cells, and we take the surface of each cell as a point coordinate. points like falling in the sea are slightly moved onto nearby land to ensure prediction remain on terrestrial areas. Then, using the DSTM model and the environmental data cube, we infer the state of species to present status. The predicted species list is then fed to another model, a large language model called PlantBird, based on Google Bird model, predict habitats, following the UNIS 2020 habitat classification. Finally, from the predicted list of species, we compute biodiversity indicators such as the number of protected local or invasive species. The result is static distribution maps that can be explored at 50 meters spatial resolution. Next one. So here you can see some data that we produce with the they include both individual species distribution and aggregate maps. You can visualize biodiversity indicators, for example, the number of species of the EU in Switzerland or invasive species in Belgium. There are also examples of alpine and Mediterranean habitats, and some remarkable species distribution in France and Greece. Next one, please. So what users can do with GeoPlanted? GeoPlanted first serves the needs of researchers and conservationists. They can explore species predictions and biodiversity needs at multiple spatial scale, from global scales and national cooperation. It allows direct comparison of GeoPlanted data with official datasets such as TB or national development. Users can also download special layers and integrate them into their own visualization or modeling or conservative planning workflow. For example, here you can see an overview of the species restoration in Greece and global reports with multiple habitats and species in details. For policymakers and non-governmental organizations, can use to support GeoPlanted to support evidence-based decision platform assess compliance with deforestation-free or regulation, and also help to prioritize restoration zones based on biodiversity indicators. These maps offer a remarkable way to evaluate environmental performance at both site and regional scales. Here, slide, you can see an example of aggregated units, habitat maps of the food in Portugal, which can directly inform policy and action. So finally, for enforcement and forensic agency, GeoPlanted provide tools to detect non-native species at ports, airports, or industrial areas, and help to monitor biodiversity change over time using pre and post event comparison. It can generate reproducible biodiversity reports that show legal investigation or environmental litigation. Next one, please. So, as a case study example, you can draw with the tool, or you can import a shape draw. So, some area of interest and observe a post-interruption drop in native richness. That's a clear forensic cycle of this. Here you can see an overview of the natural reserve of Bagnac close to France. Next one, please. Yes. So you can explore the tool at gmail.com or scan here. Technically, it is built on nuts and leaflets for the front end, and mostly Python script for the backend. You have max proxy for cache server and tiler for map surveying. And download the maps as OT files. It's actually cloud optimized geotiff that you can download from Snap Catalog. And you can also add the layers to your geographic information system as WMS layer. We are currently working on a new model version that will integrate probability directly with the layer, improve confidence. And for a long time future, we have to be fully integrated in the model, and we plan to expand more. But thank you for listening. I will be happy to answer one question.
We have time for some questions.
Very great work. Two related questions. One is, how are you dealing with undersampled species for which you have very little data? Other work shows that they tend to be worse performance with machine learning models than they already do with traditional estimates. And so what is the validation there for the undersampled species? And second, you've been using the term probability. I'm curious how you define that, because are you using absence data and are really able to arrive at present probabilities, or maybe certain ones to that?
For the very specific species, we all have the same problem. Like the model doesn't predict well with lack of data, so we have better result for sure with suspicion with data. That's for sure. So we don't have a special treatment for this species in your content. We try to get more data to improve the results. That's the way we are dealing with. We also work on the threshold for the model, like it's I would say a perpetual adjustment between very common species, rare species. Like if we move the threshold of the model a bit, we have a very significant differences in the model performance, I would say. For the evaluation, we have created a challenge, a kind of challenge called GeoLifePlay, where a lot of people can contribute their models, and that model was directly created on the challenge. It's where we evaluate every years. You can do it. I don't know about it later. And for probabilities, I'm not a specialist, so I will probably answer it correctly. Maybe Pierre can help me on that subject.
What we can mention is that we use a European Vegetation Archive, which is a present absence data set produced at European scale, so massive volume of data. And so the data are used during the training and for the evaluation. So it allows to calibrate the model training, and then when we evaluate the prediction, is evaluated on presence absence data. And so this really transformed the way we were able to produce such map since a few years, because we only use that data set, EVA data set since 2 years. And so it's really transformed our capacity to better predict absence of species in place where we're not aware about that absence. So for the calibration of the threshold, so there is a PhD student who work on that in order to identify the more accurate way to filter its predictions, but to normalize it in order to have, to say, coherent map. So until now, the tool is available since a few months online. So we start to have feedback from expert users. Push us in the right direction. Thank you very much. I think that we'll have to move to the
Yeah.
next presentation. Yeah, so, the next presentation, thank you, Christophe, will be done by, Sandra Rousseau. She will, present the work on vital implementation. A best work scaling survey on gravity criteria. So it will be the last, virtual presentation that we have to stage.
Oh, no. Oh.
Today, I would like to give a presentation on experts' insights regarding gravity criteria and reduce the access biodiversity damage in contexts such as terrorism, sanctions, prosecutions, and more. We gathered the information through a survey with experts for policy, practice, and research, and I'm happy to discuss some key results. This research is part of a larger project in which we aim to develop a comprehensive, individual-based decision-making tool to assess damage to individual specimens of plants and animal species and small-sized ecosystems. This tool should be useful in both legal contexts, such as permitting economic activities, and illegal contexts, such as sanctioning offenders. And to this end, we investigate existing gravity criteria within 3 different disciplines: law, economics, and ecology, and created an integrated framework based on these building blocks. In this specific study, we focus on the relationships between these gravity criteria and on what people from policy and practice consider important. We aim to strike a balance between what is scientifically necessary, according to the experts, and what is workable in practice. The proposed framework distinguishes a set of 26 criteria for assessing harm to individual plant and animal species. To structure the gravity assessment, the criteria were categorized into 4 main conceptual groups: an ecological, regulation, social, and ethical category. The ecological criteria capture the biological and ecological characteristic relevant to the individual specimen, such as the conservation status of the species, its ecological function within the ecosystem, and traits derived from population dynamics and life history. Remediation criteria assess the potential for and the feasibility of restoring the damage caused, taking into account aspects such as remediation potential, time required for recovery, and associated costs. Thirdly, social criteria. They reflect the cultural and societal importance of the specimen, encompassing values such as aesthetic appeal, recreational use, spiritual meaning, and legal progression. Finally, the ethical criteria consider the normative dimension of biodiversity harm, including the necessity and intent behind the action. In order to analyze and learn about policymakers and practitioners' point of view regarding those 4 groups of criteria, we use a survey. The survey consisted of 3 main groups. First, we started with some introductory questions. Next, the respondents were presented with a general case involving biodiversity damage. They were asked to indicate which of 5 criteria they found most and least relevant, applied to a specific specimen, plant or animal, based on our current list of severity factors. They received several questions each with 5 different criteria. This best first scaling method was selected because it enables the evaluation of participant use across a wide range of issues while minimizing the cognitive burden associated with choice tasks. The results from the best worst scaling exercise allow for a quantification of the relative importance of weight that respondents assign to each gravity criterion, ultimately providing a ranked ordering of the criteria. Finally, the participants answered a few concluding questions, for example, about their environmental act. In the spring of this year, we collected a data set of 143 participants, with a little bit more female, a bit more male than female respondents. We had a diverse group in terms of age. 3/4 were Belgians, and looking at the disciplinary background, we see that natural sciences, so we see a group from natural sciences, environmental science, or bioengineering, and law. That are the three main groups of disciplinary background. Regarding the professions, lots of them were, 1/4 of them were a civil servant. We had researchers, academics, consultants, and scientists. People could select more than one of these groups if necessary. So so to begin, we asked our respondents to look at the 4 main categories of criteria and to assign a weight to these criteria. So they had a weight of 100%, and they could assign it to these 4 groups of criteria. As you can see here, the main group or the main weight was attached to ecological criteria with 46%. With 29%, the remediation criteria followed closely, and then we had the social and the ethical criteria who received approximately a similar weight from our sample. So this best worst scaling allowed us now to calculate scores that reflect the average importance of each criterion based on all the respondents' choices. The higher the score, the more important the criterion was perceived. First, the results shown here show that the ecological factors such as ecological role, regional extinction risk, local extinction risk, and total impact on the population received the highest scores. This means that these factors were considered the most severe or important. Interestingly, regional extinction risk was rated slightly more important than local extinction risk, which was ranked higher than global extinction risk. Secondly, we see that remediation factors such as time to recovery and recovery potential receive average scores, indicating that they are considered moderately important. Third, we observe that uncertainty is an important factor for some respondents, both in terms of overall uncertainty about the damage and specifically the uncertainty surrounding remediation outcomes. Finally, social factors and ethical factors are seen as less important, except for the legal protection status of the species, which scored high. So if we look into the detail in having these results, we can actually distinguish 3 different classes. One class that is focusing on remediation law. This is approximately 30% of our sample, and they value criteria related, such as the remediation potential, the cost, and the time for which remediation occurs. The second group focuses on ecological criteria, and this is almost half of the sample. And this group prioritizes these ecological aspects, such as the ecological rule, extinction risk, and the impact of on local populations and renewable capacity. The third group, as the smallest group, 22%, can be described as uncertainty for us. This group places the highest importance on uncertainty related criteria, including the uncertainty of damage effects and the success or the potential of remediation. If we look at the different patterns underlying these 3 groups, we see that policymakers and practitioners are more likely to focus on remediation, while researchers are more likely to focus on ecological criteria. People with a law background are more likely to focus on remediation as well, while those with science background are more likely to focus on ecological criteria. And finally, people with a high score regarding environmental attitudes seem to focus more on remediation, while those with a low score are more likely to focus on uncertainty. So, to conclude, this study contributes to the further development of decision-making for assessing biodiversity and policy implementation. We use an interdisciplinary approach and focus on applicability and relevance for practice. We have similar results for the ecotopes, which I have not presented here. Thank you for your attention. Yeah. Exactly. Our research.
Enganchito, mira.
There's a contact and the contact here for questions. That's the best way. Same schedule. We now have Nicolas Martinucci and we have a topic of AI.
We want to try this one and use here and having the
Yeah, ready. So I'm Giulio, a PhD student in computer vision applied to ecology, and I'm glad to present to you Plant Clay 2025, a public benchmark on multi-species plant identification in vegetation quadrant images. So first of all, change. Forgot. Change. So first of all, plant biodiversity monitoring is particularly important in environmental forensics application and law enforcement, since it provides ecological evidence on climate change, habitat disruption, or spread of invasive species. Also, using specific biodiversity indicators can help to estimate ecosystem health and revealing some decline on pollinator services or soil and water resources. Change. So traditionally, the vegetation surveys are carried out by botanical experts that identify one by one the plant species in a sampling frame called quadrat in ecology, and of typically of size 50 times 50 centimeters. However, this method is hardly to be scalable at space and time level, as it remains very time consuming, expert on knowledge, dependent on knowledge expert, and very expensive. For this reason, change please. A promising alternative is to automate this process using AI, in particular deep learning models that from a high resolution image of the plant communities can predict the plant species. So from a machine learning point of view, the task can be framed as a fine-grained, weakly supervised multi-level classification, where fine-grained refers to the high ambiguity between plant species, while weakly supervised is referred to the fact that, please change. We actually do not dispose of a very large annotated dataset of quadrat images, spatially dense on a big flora. So for this reason, we share to participants deep learning models similar to PlantNet, trained on single plant images. That so generates an important shift between training and test set. Change, please. So looking closer to some example of vegetation images, species identification is particularly hard because, change please, the plants often overlaps in the quadrat. Also, change, because of the phenological variability of plants across different seasons. Thank you. The high ambiguity among a large number of species that is particularly accentuated in this type of images because less detail is available. Also, please, some species is particularly hard to be detected because of their little size, and is also important to handle region with no with no vascular plants. Change, please. So in terms of data set, we shared single plant images data set from PlantNet, covering almost 8,000 plant species in southwestern Europe, while the test set was composed by almost 200 to 2,000 quadrat images. Another data set of vegetation communities not annotated was also provided to participants, but for the moment, any of them found it valuable. Change, please. Also, in terms of metric, we used a classic F1 score to evaluate the performance on quadrat level, while global data set to reduce the bias of oversampling zones. We firstly average the scores on the quadrats that are surveyed in the same region. So the competition was hosted on Kaggle platform and attracted a quite large number of participants worldwide. In particular, nine teams also published working notes about their methods. Now let's see some insights about the results. As you can see, the winning team attained almost 30%. This is also quite low, but with a clear progress compared to last year. Change, please. So most of participants used our foundation model fine-tuned on the training data set, the DinoV2, and used it with the tiling configurations and consist on splitting the images, predict on each of tiles, and then aggregate predictions. A few participants also try to use metadata that can induce some bias. So if we consider just the visual approach, we are just on 35%. Change, please. So concerning the winning method, the core of its approach was using classical preprocessing methods to reduce the shift between train and test dataset, and in particular, reducing the effect of the impact of resizing. It's important to notice also that some team overfits on the public leaderboard using too many parameters. And some teams tried different interesting approach to handle non-vegetative content. In particular, the best approach was a combination of 3 foundation models, the grounding Dino, SAM, and DinoV2. So while it's quite effective, it's a bit too much costly to deploy in production. So to conclude, quadrant monitoring with AI is a promising scalable tool for plant biodiversity monitoring, but still remain a high complex task and needs a great research effort. In terms of the methods, the image preprocessing and the background rejection are important to stable the model performance, while using too many hyperparameters lead to overfitting on public leaderboards, limiting generalization. So if you are interested in, we are replicating the same competition next year, and great thanks to Plantago Eco that funds my PhD. Thank you.
then I would ask the training. Oh, yes, okay.
Yeah. Any of the participants?
No, yeah, the winning participant made a very clear comparison between the tiling approach and the high resolution. So like just applying on the entire image. For the moment, the best approach was reducing the image to the model size, so 1518. And with a great performance, but still the best approach was like 7 scaling, like consider like almost 100 of tiles for each images. That is very costly also. So it's also another problem.
One more question. Any of you take the training?
No. Yeah. So for the moment, yeah. No, because we don't. As I said, we don't have now a large data set to train a multi-label model. We could use. So yeah. We need a very dense, especially distribution data set to import it in the model. If not, we risk to overfit on a specific flora or a specific zone. Thank you. Yeah.
So hi everyone. So I have the chance to conclude this session. So thanks again, Christophe, for the organization and the opportunity to share such diverse work related to forensic investigation. So what we could see is that the diversity of direction followed by that session was quite diverse. And we hope that it will open a new avenue within the TADWIT community in particular, because we can see several research activities conducted in order to have more ready-to-use data and services. And when we imagine to use such results at the jurisdiction level or for forensic investigation, it really pushes us to push the boundary and the confidence on which we can take decision for a court, for example. So I hope that session will really push research activity in that domain. So I'm botanist working at CIRAD, which is a French research institute in agriculture for development, and I coordinate the PlantNet citizen science platform since 15 years. So the work that I will present has involved a large diversity of colleagues, ecologists, botanists, IT engineers, and computer scientists. And so the work that I present is some reflection and example on how AI-based citizen-generated plant observation could be cautiously used for forensic evidence in a biodiversity-related investigation. So it's related to the EU Deforestation Regulation context that require an increasing needs for verifiable environmental data to trace illegal activities such as deforestation, trade of protected species, or habitat destruction. Can you move to the next slide, please? Thank you. So let's start with the context. So as we are all aware, deforestation, biodiversity loss, biological invasion, and climate change are interlinked and unfortunately accelerating. So for example, EU Deforestation Regulation require evidence that trade products are deforestation free, but such evidence is often difficult to obtain because it requires spatially precise, timely and verifiable observation. And citizens-generated observation, which are now produced at massive scale through citizen science platform like iNaturalist or PlantNet, could help to fill this evidence gap, providing a near real-time ecological signal that completes satellite data or administrative report. Can you move to the next slide? Thank you. So we are unfortunately seeing an increase in environmental crime, and authority now needs a much scalable evidence source. So citizen science platforms, through millions of smartphone-based plant records, already produce near real-time biodiversity data that include images, timestamp, and GPS position. You can see on the map on the top right corner the distribution of PlantNet occurrence share on GBIF, and more or less every year. So this is a graph on the down right corner illustrating the volume of the number of users for this year. So even if we were not at the fully end of the user, we almost reached a volume of 20 million of people who use the platform. Half of them share their geolocation and then contribute to produce a massive volume of plant occurrence at the world scale. So this data could be extremely valuable for due diligence process, such as compliance with the EUDR framework, but only if we can ensure their reliability, traceability, and admissibility as evidence in front of a court. So the question is, can we use them responsibly in such legal context? Can you move to the next slide, please? So let's start with what is a typical citizen's observation at present time. So this observation include most of time one or more images, geolocation, timestamp, user ID when they create an account, device metadata, and suggested identification that are all stored with a specific license. Most of citizen science platform push for a Creative Commons license, which really increase the capacity of reuse and the benefits of such observation, even for legal investigation. Platform apply different validation mechanisms. Some of them can be combined, such as the community review, expectoration, and increasingly AI-assisted quality control. So this makes such observation structured and traceable data object, which is a good foundation for their potential use in a forensic context. Can you move to the next slide? So we could see an increasing role of AI in such pipeline in the past few years. So automated identification models, like those we mobilize through the PlantNet platform, now work at the volume of several dozens of thousands of plant species at the world scale. So you have some statistics on the top right corner that illustrate the volume of flora, the volume of species that we cover at the world scale. So at the present time, we cover more than 77,000 plant species at the world scale. And the full platform, since its beginning, has received more than 1.3 billion of identification requests. So through this huge volume of identification requests, there is potentially key evidence that court could take into account and could use for investigation. So AI can help to flag anomaly, for example, the appearance of regulated invasive species in protected area. It can also support triage by custom or environmental agents to rapidly suggested species identity from an image of a plant part. So of course, this raises a question about model reliability, uncertainty, and validation that I will develop soon within this presentation. Can you move to the next slide? So here I will introduce two concrete use cases in which we were mobilized. So this one is led by DEAL of the Reunion Island in the Indian Ocean that used real-time PlantNet occurrence generated through the platform on that island to monitor the observation of more than 670 potentially invasive species in that island. So this means that they have a target list of species that they want to track. Some of them already present, some of them never observed within the island, and they use the platform in order to have almost a near continuous and real-time monitoring schema for the plant introduction and spread that complete classical and formal investigation and report. So such data can reveal early invasion and also the persistence of some invasive species despite eradication campaign, which can support investigation in potentially illegal introduction or trade. Can you move to the next slide? So the second example is an example that have been implemented within the context of a Biodiversity Plus pilot on invasive species again, and that have been mobilized. So in that context, a network of actors through 11 European countries use onboard camera on the top of a roof car that generate quite large visual data stream and that are automatically processed through the PlantNet API that allows the detection of key invasive species that they want to track across Europe. So this work was focused on 15 invasive species at the European scale, and it has demonstrated how such a data stream with AI detection can produce massive and standardized evidence for biosecurity surveillance. So this approach can support forensic investigation, but only if data integrity and model reproducibility are well described. Can you move to the next slide? So to make citizens and AI data forensically useful, we have to think about investigation readiness. So this means that we have to define a clear chain of custody from data capture to report with a timestamp, with model versioning and reproducibility of the result. In short, we need to process all the data in order to allow an authority or a court to verify what model, what version, and what data lead to an observation and an identification that can be used. Can you move to the next slide? So reliability is at the core of this investigation. So identification model perform well on a common and invasive species, but much less for rare taxa. So since 2011, we conduct international benchmark. So the previous presentation introduced plant cleft in the past 2 years that moved to the analysis of plant community. And so this long-term benchmark allows us to evaluate the capacity of large diversity of AI model in different contexts. For forensic purpose, the difference is that compared to the context in which we were using that platform and that service in the past, we need to well quantify the uncertainty and appropriately define the confidence threshold that is adapted to the use case for which the AI services and species identification services will be used. Human experts must remain always in the loop, and especially when legal decision and sanction depend on such detection and identification. Can you move to the next slide, please? So, of course, these citizens' observations are not perfect. So they are biased toward accessible area or popular species. And unfortunately, mislabeling training data or poor quality data can mislead models. So we have to be aware of that, and we have to well calibrate the use of these services in order to identify the correct and precise threshold to which we can mobilize such observation in a jurisdiction and legal decision. So there is several mitigation strategies that can be implemented for the management of such observation. But what is important is where and why model fail, which is essential for their forensic use. Can you move to the next slide, please? So beyond science, we must address legal and ethical issues in such context. So for data to be admissible, method must be transparent and auditable. So licensing and the use of Creative Commons license in particular and privacy protection under GDPR regulation are critical to allow the use of such services in forensic context. We must ensure that the user, so using citizens' data in investigation never endanger contributors or misuse their contribution, and that biodiversity protection remains the main objective. Can you move to the next slide? Thank you very much. Here are some examples that in which such a workflow could work in practice. So the use of AI image identification services to support custom officer, or the detection of illegal cultivation in protected area, combining with occurrence coming from satellite or ranger logs. So these are promising workflow, but they require cross-validation and expert confirmation before any legal interpretation. Can you move to the next slide? So finally, here are a few open questions. So can such observation ever have a probative value in court? How can we verify aerial prediction and geolocation with a legal rigor? And what governance models are needed in such context for high-risk species or critical event? So answering this question will require collaboration between data scientists, ecologists, legal experts, and social scientists to design responsible workflow for the forensic use of citizens' biodiversity data. So can you move to the next and final slide? So to conclude this collaborative effort supported by several national and European projects, we want to mention the fact that the idea with such objective is not to turn citizen science into surveillance, but to responsibly unlock its potential for environmental justice and a better protection of our biodiversity. So thanks again for your attention.
Session on